So today we are going to do section 1.4, chapter 1.4, inverse functions. We are only doing review right now, so I will just go over briefly to sort of remind you what's happening. The inverse function is a function that brings everything backwards. As an example is, for example, the let's see, let's find an example here in your book. Well, anyway, so let's consider the function f of x equal to x squared. This is section 1 point something, 1.4. Okay, we're in 1.4, and let's look at the function of the basic fx equal to x squared. What is the inverse function? This function squares stuff, right? So the inverse function takes the square root. So if you have an inverse function, which is written like this, normally the -1 exponent means 1 over something, division or something. But in terms of functions, it means inverse. Has nothing to do with division. So the inverse function is the square root of x. So whatever that does the reverse is called the inverse function. So this function squares stuff. This function takes the square root. Kick it right back. An inverse function can only be defined in parts of the function where it's 1 to 1, because because when you say let's say x is 4, right? You take the square root of 4. What does it become? Well, it can be either 2 or -2. And but a function has to have one answer. It can't say, oh, it's either 2 or -2. You will define it. You will define it as just one thing. Normally, we define it as 2, but if you insist on defining it as -2, that's fine too. Just need to be consistent. And that your function, for example, you can have one function that gives you the positive root, another function gives you the negative root, which is perfectly good. Moving along, find the inverse function. Normally you find the inverse function. Okay, normally you find the inverse function by digging it out, okay, so to speak. Such as, let's look at a very simple example. Example 1.29. Let's look at this particular example where we have f of x equal to 3x minus 4. How would you find the inverse of this thing? To find the inverse, you call f of x y equals 3x minus 4. Why do you call it y? It's habit, tradition. All right, and then now we're gonna isolate x. So the x stands by itself, and everything else get pushed to the y side. So to do that, you solve the algebra equation. Move 4 over there, it becomes a plus, y plus 4, and then move the 3 down here. Divide by 3, so then you have x equal to that, and that would be your inverse function. So then f. For this particular f, then the inverse function is called x plus 4 over 3. Now we change the variable back into x, but it doesn't really matter what variable you use. Okay, is in a function, that's just a placeholder. You can call it anything, just like calling your son George or Peter. Doesn't matter. It's still the same son. So the variable, that would be the inverse function of that thing. All right. And often you have to think about the domain of the function. But in this case, the domain is whatever, right? And so is the inverse function. It all works out because it's just it's only a linear function. Well, this particular inverse function, of course, then you have to worry more about the domain. And then you pick a point where you inverse from, or to. Moving along. and then you draw some graph of the inverse function. The inverse function has a tendency to be reflective along the y equal to x line. Say that is, if you have a function, this is your original function, okay? Some random thing. The inverse function will be the mirror image along the y equal to x line. That is the 45-degree line, and you just flip it over and it becomes the inverse. Why is that? It just works out that way. It's just a small point of interest. And as always, when you work on inverse functions, you have to find the domain. And inverse functions are not always possible on a large scale, but it's always possible in a small scale. There are only parts of the function that you can flip over. And there are other parts that flipping over doesn't make any sense. Okay, so next. The inverse trigonometric functions are similar. You flip it over, okay? Like you use inverse trigonometric function all the time, but most of the time people don't talk about it. For example, like say if you have something called sine of x. Sine of x, let's say sine of x equal to, I don't know, pi over 3, okay, which is 60 degrees. Then what is x? Instead of x would be, strictly speaking, sine of pi of inverse of pi over 3. But normally we don't write that. We simply remember the x is, you draw that little triangle, 1, 2, square root of 3 by the Pythagoras theorem. Here's pi over 3, and the sine is defined as opposite over hypotenuse, so square root of 3 over 2. So, which, sorry, I said that wrong. Sine of x, yeah. Anyway, what I mean to say is sine of x is square root of 3 over 2. All right. Sorry, guys. Anyway, so sine of x is square root of 3 over 2. All right. So x, what is x? So sine of x is actually the ratio, right? So 3 over 2. So what's x? X is pi over 3, 60 degrees. So, but normally you don't even say that. You just, if sine of x pi over 3 over 2, you just figure out in your head or the calculator that it is pi over 3. So, so I don't think the inverse function is that big a deal, especially during the review time. So let's move along. Flip. Next, let's not do any more inverse trigonometric functions. And with that, we finish section 1.4. The student project, let's skip the student project. Being that we're in review, I don't see why we should waste time doing projects. Because we need to get a move on. Okay, let's move right on to get to calculus.